Hello, I will show you how to solve stoichiometry problems. This is the first of the problems that you are going to solve in this class. This is actually the simplest one, where we transform from mole of one substance to the mole of another substance. So this type of problem is known as mole to mole conversion. So let us look at an example that gives us an idea how this problem is solved. Let's suppose we have 8.53 mole of C8H8, that is octane, and the octane is undergoing combustion reaction to form carbon dioxide. So what we want to determine is how many moles of carbon dioxide will be produced. So this is based on the reaction equation shown. So this is our reaction equation. The whole problem will be solved based on this reaction equation. Now let's see, how should we approach it? First of all, you need to determine what your given quantity is. So I said that you can find the given quantity from the problem that you are given. In this case, our given quantity is 8.53 moles of octane, that is C8H8. So how do we solve this problem? We start with the given quantities times the conversion factor. So in this case, we are given 8.53 mole. What we need to do is just to look for a conversion factor that is going to give us our answer. So let's look at that. Here we see that we are given 8.53 mole. Our conversion should make sure to cancel this. What we want is to cancel more C8H8. So if you want to convert anything at all, we need to draw a line here and divide by these moles. So what we are saying is this should be multiplied by more C8H8. There will be a number here, but what we are looking for is to make sure that this cancels with this thing is messing me up. Cancels with this one. That's what we want. So these cancel, and then we think about what do we put at the top here. At the top here, what we are looking for is to determine the moles of carbon dioxide. So we know down here we have moles of octane, which means up here we need to put the moles of carbon dioxide. Now, in terms of the numbers, what do we put? Here we see that for every 2 moles of octane, there is 16 moles of carbon dioxide. So for every 2 moles of octane, there is 16 moles of carbon dioxide. So in terms of our conversion factor, we can put here 2 moles, here 16. But let's think it this way. So we have 16 divided by 2 moles, which gives us 8 divided by 1. So what it means is that here we are going to put 1 mole of octane, while here we put 8 moles of carbon dioxide. That is going to give us the moles of carbon dioxide we are looking for. So if you look at this problem again, you see that this cancels with this, so that in the end what we are remaining with is just this one. This is what we are remaining with, which gives us here the moles of carbon dioxide. So let us put the numbers in and see what we are going to get. So I'm just writing the same problem again. This is our 8.53 mole of octane times the conversion factor. So we said here we put 1, here we put 8, which means for every 1 mole of octane there are 8 moles of carbon dioxide being produced. So this gives us our answer as 68.2 mole of carbon dioxide. So that's how we solve this problem. You can see we are moving from mole of octane to mole of carbon dioxide, and there is only one conversion factor. So when you solve a problem that has moles and you want to form moles of the other reactant, there is only one conversion factor. So this is how we solve this problem. Thank you.